Hello, today we're going to look at some right triangle applications, and specifically we're only going to be working with one right triangle. Now the process that I follow when I'm solving a right triangle application is the following. So I read the problem and I draw a picture of the right triangle, and then I label everything they tell me that I know and everything that I want to know relative to the given angle. And I use the terms opposite, adjacent, or hypotenuse. And of course I fill in the numbers. I then choose the trigonometric ratio that contains the side that I know and the side that I want to know. I set up my ratio, I go ahead and figure out what the trig function of the angle is, and then I solve for the unknown. So let's take a look at a specific example. So here we have a car sights a hot air balloon 1.2 miles from the point on the ground directly under the hot air balloon. The angle of elevation of the initial sighting was 30 degrees. Approximately how high was the balloon at that moment? Now, first, if I'm going to go ahead and talk about drawing a picture, they gave us the picture, but say they hadn't. Well, they tell me that I have a hot air balloon, so I would draw this, something like that, and then that the car sights the balloon 1.2 miles from the point on the ground directly under the hot air balloon. So under the hot air balloon, the point on the ground would be right there, and then there's a car a certain distance away, which they tell me is 1.2 miles. Now, the interesting point here is they say the angle of elevation was 30 degrees. So let's talk about angle of elevation and angle of depression. Angle of elevation is an angle measured upward from the horizontal. So this is my horizontal, it's the ground. And if I measure upward from that, this is what I'm talking about. This is 30 degrees. Now, of course, this perpendicular vertical and horizontal lines gives me my right triangle, or my right angle, making this a right triangle. So that's how I would know how to draw the picture, okay? If they had given me an angle of depression, like maybe the hot air balloon was looking down and sighting the car, then in that case the angle of depression is measured downward from the horizontal, but in that case you'd have to have a horizontal like this, where here's the balloon, and downward from that, from this horizontal, that would be the angle of depression, okay? So, now let's go ahead and go through these pieces then. What I would now say then is, I've got my picture. I now want to label what I know and what I am given. So let me make this a little bit stronger so that you can read it. We have here a right triangle. This is 1.2 miles, and this is 30 degrees, and I want to know h. So relative to the angle they gave me, this side is the opposite, and this side is the adjacent. Always across from the right angle is the hypotenuse. So opposite, adjacent, the angle in a sense cuts through the side, and then hypotenuse. So now what I know is this adjacent side. What I want to know is this opposite side. So I know this. I want to know the opposite side. So now I look at my trig ratios and I say, what is it that involves the opposite and the adjacent? So I look down and I can see that it's tangent and cotangent. Both of them have opposite and adjacent. Now you could use either one, but truthfully, when you look at your calculator, you can see that your buttons are for sine, cosine, and tangent, and these functions above it are for inverses, not reciprocals. So really, it's easier to work with sine, cosine, or tangent. So I'm going to go ahead and pick tangent, opposite over adjacent. And I'm going to go ahead and start solving this then. So now what I'm going to say is that based on this picture, I'm going to say the tangent of an angle is the opposite over the adjacent. In our case, tangent of 30 degrees is the opposite is the height, the adjacent is 1.2. Okay, so now that I've done that, all I have to do is go ahead and evaluate tangent of 30 degrees in my calculator, and when I do that, I'll get 0.5774. And now all I have to do is multiply both sides by 1.2. All right, so I'll get that h is about 0.7 miles. Okay. Now, could I have done this with the cotangent? Yes, I could have. Let's go ahead and do that just so you can see what that looks like. If I had decided I wanted to go ahead and handle this with cotangent, all right, I would have said cotangent of 30 degrees is the adjacent, which in our case is, let's take a look at that picture again. Here we go. Adjacent is 1.2. Over the opposite is h. All right. Now, because I have to work with the reciprocal, I know that cotangent is 1 over tangent of 30. Okay? And I still have to evaluate tangent of 30, which we know is 0.5774. And now you still have to solve this, so you can cross multiply, for example, and say h times 1 equals 1.2 times 0.5774. And of course you're going to get about this, you're going to get the same answer, right? 0.7, I didn't really need that, miles. All right. Thanks for listening.